Oh, you know it. It's another day of math here with your buddy TallTal. How's everybody doing? Welcome back. Today in our math video, we are going to talk about multiplying fractions. That's right. It's getting real. Just like I like to think about the penguins. They're always getting real. Hey, you know why penguins carry fish in their beaks? They don't have any pockets. Duh. Well, why'd you guys think they had pockets? I mean, what are you thinking? All right, today we're going to multiply fractions that include denominators of 12 or less. We're not going to go into those crazy huge numbers. And the answers we're going to express in simplest form. So if you haven't watched the modeling of the multiplication of fractions, do it. It's amazing, and you'll understand how fractions multiply and what that means when they're conceptually when they're multiplying together. Today we're going to dive in a little bit more to the idea of how to step by step go through solving multiplying fractions. First of all, let's talk a little math lingo. When we multiply fractions, what we are saying is we are taking part. So a fraction's a part of a whole, right? We're taking part of another part. We're taking a fraction of a fraction, okay? So notice that I highlighted that the of in yellow, okay? Because we're going to go back to that, okay? So when we look at a fraction, 1/2 times 1/4, what we're saying is we are doing 1/2 of each of the 1/4. So if you take, for example, just think of a banana. You cut the banana into 4 pieces, all right? So you cut it into fourths. We're going to take 1/2 of one of those fourths. So you would take your fourth, cut it in half, and that's the size banana you would have. Okay, so we're taking part of a part. As a most of the time rule, when you're thinking about math, when you see the word of, it means multiply. That'll help you going forward. So take a look at this. We have something cut into fourths. We have a pizza cut into fourths. This is 1/4 of a circle, okay? What would 1/2 of each of those 1/4 look like? So it's this pizza or this circle's cut into fourths, and so now I've cut it into eighths, okay? Or I cut each one of those fourths into a half. Let's look at that again. Here's a fourth, so just pay attention to the green as this other circle comes on top of it. So when I bring that other circle up, I took half of the fourth that was there, half of the green. So what would 1/2 of each of those look like? It would look like this, okay? We only need 1/2 of that 1/4. So what would that look like? So when I cut that fourth in half, what you see is I cut 2 pieces, all right? So I cut it in half, but we only need one of those halves. So what would it look like, okay? It would look like this because we only needed one of them. So what would our answer be? It would be 1/8 because we have one colored in out of all 8 of those. Part of a part, okay? All right, let's go forward. Do you notice anything with that answer? All right, so look at the problem. 1/2 times 1/4. Do you notice anything about that answer? Well, some of you did. Yeah, you just multiply the numerators and you get 1. 1 times 1 equals 1. And when you're multiplying same thing with the denominators. 2 times 4 equals 8. So when in addition and subtraction, we had to worry about getting common denominators and all that fun stuff before we could even get to the addition or subtraction. In multiplication, you don't have to. That's just how you multiply fractions. You multiply straight across. You multiply the denominators, and you multiply the numerators, and then you multiply the denominators. I don't know. I've never said the word nominator in my life. Here we go. Interesting. Okay, so here's a little bonus feature that you're going to want to know. It makes your life real easy if you understand this bonus feature, okay? When we are multiplying fractions, before you do it, there's something you do to make your life easier. And here's what it is. You can simplify diagonally. So you can look at the numerator on one side and put it with the denominator on the other side, and we can simplify that. So think of that as 4 over 12. So think of that when you're looking at it as 4 over 12. Can you simplify that? Is there a number that will go into both of those? And you could figure out your common factors, but you would probably be able to tell that yes, 4 will go into both of those. And how many times will 4 go into 4? It will go into 4 one time. And how many times will 4 go into 12? Well, 12 divided by 4 is 3. So we can literally, if we know that, we can take this 4, turn it into a 1 because 4 divided by 4 was 1. We can take this 12 divided by 4 was 3. Now we can do the same thing with the other one. Okay, look diagonally. And this won't always work, but in this instance, it works twice. So now we can say 3 and 9. Can that be simplified? Is there a number that will go into both 3 and 9? And yes, 3 will go into both 3 and 9. How many times will 3 go into 3? It will go into it 1 time. And how many times will 3 go into 9? It will go into it 3 times. Okay, and now we've simplified our fractions before we multiply, and that makes it a lot easier because then we could just say 1 times 1 is 1, and 3 times 3 is 9. Okay, that's pretty simple. And if you didn't do it that way, guys, if you didn't do it that way, look how much more work you'd have to do. What's 4 times 3? It equals 12. And what's 9 times 12? It's 108. And now we got to go through and simplify. Find numbers that will go into both of these, okay? And so you'd be, maybe you divide by 2, maybe you divide by 4, but you would just keep simplifying to get to the answer. A lot of times when you simplify diagonally, it ends up giving your answer in simplest terms or real close to it. All right, so let's give this a shot, okay? Next slide. So let's do a little practice here. Multiply across, then simplify. That's the only rules we have. So multiply across, but first, can we simplify? So this is an example of looking diagonally, 3 and 4. Is there a number that will go into both 3 and 4? Just 1, so that can't be simplified. And if you have a 1 involved, like this one, 1 and 5, you can't simplify because 1 is already completely simplified. So in this case, there's no simplifying we can do first, all right? So we just simply multiply across. What is 3 times 1? It equals 3. And what is 5 times 4? It equals 20. And then we ask ourselves, can we simplify? Is there a number that will go into 3 and 20 where there's only 2 numbers that go into 3? Okay, and what are those 2 numbers? That would be 1 times 3. Okay, and 3 is never, or I'm sorry, 1 is never going to simplify anything because it just keeps it at the same answer. Will 3 go into 20? And if you understand your 3 times tables, it does not. But if you have to count by 3, 3, 6, 9, 12, 15, 18, 21. We skipped 20, so it cannot. So this is our final answer. It's in simplest terms. All right. What about this one? All right, first thing, can we simplify diagonally? 3 and 5. Can we simplify? The only numbers that go into 3 are 1 and 3. Will 3 go into 5? No, it will not. So that can't simplify. What about 2 and 8? Is there a number that will go into both of those? And probably pretty quickly you said, yeah, dude, 2 will go into both of those. How many times will 2 go into 2? Well, it goes into it 1 time. Okay, so we turned that into a 2. And then how many times will 8 or 2 go into 8? It will go into it 4 times, okay? So now we can go ahead and solve this problem because we have simplified before we moved along, okay? All right, how many times, what is 3 times 1? So we got this 3 and this 1. What's 3 times 1? It's 3. And what is 4 times 5? That is 20, okay? We're back at that same situation. We have 3 and 20. Will 3 go into 20? It will not, and that's the only factor that 3 has, so this is our final answer. You're already simplified. All right, let's look at another one. Can we simplify diagonally? Okay, let's look at this 5, and let's look at this 10. Is there a number that will go into both of those? And the answer is yes. 5 will go into both of those. How many times does 5 go into 5? Goes into it 1 time. How many does 5 go into 10? It goes into it 2 times, all right? Now let's look at the other one. So the other diagonal options are 3 and 12. Is there a number that will go into both of those? Well, if you count by 3, 3, 6, 9, 12. Yes, 3 will go into both of them. So how many times will 3 go into 3? Goes into it 1. How many times will 3 go into 12? 3 times 4 is 12. Or 3, 6, 9, 12. So 4 of them. Okay? 1 times 1 equals 1. 4 times 2 equals 8. We have a 1 involved in our answer. It's simplified. Can't get any simpler than that. All right, and that's it. That's as simple as it is. Can you dig it? Of course you can. Hey, what's black and white and goes around and around and around and around? Yep, that would be a penguin stuck in a revolving door. It's a penguin day. Let's multiply some fractions. Round and go. Bye-bye.